Topic 6.8, the conservation of magnetic energy. Suppose here that a body under displacement of, in this case, displacement of del x under a conservation force. So, according to work energy theorem, del A is equal to f of x into del x, f of x into del x. If conservation, in this case the potential function v of x minus v is equal to f of x into del x. Now next, above the in the equation, so total energy, total mechanical energy is equal to potential energy plus kinetic energy. Okay, total mechanical energy is equal to potential energy plus kinetic energy. Now kinetic energy plus potential energy is equal to 0. Okay, so now here in this case del A plus B is equal to 0, which means that here in the sum of potential energy and kinetic energy is equal to 0. Sum of potential and kinetic energy of the body is constant, but individually suppose increase this value, so in this case potential energy increase, so here kinetic energy decrease. So in this case potential energy increase, so same amount of kinetic energy also decrease, so is equal to total energy of mechanical energy is equal to constant. No change in total energy, means total energy in this case is conservations, mean in this case final and initial case, so AI plus AI is equal to final plus, now this portion initial total energy is equal to final total energy, potential kinetic plus potential, kinetic plus potential energy. Now here in the first case, some of the definition of the conservation force. In the f of x is conservation if we derive a scalar quantities v of x by a equation is del v is equal to minus f of x into del x. Okay, now second one is work done by the conservation force depend only on the end point. Only and end point, not depend on path, not depend on path, only and only in the end point, means work is equal to, in this equation is af minus ai is equal to x minus I, means final kinetic energy minus initial, final potential energy minus initial in this case. Now next one is, third one is not depend on the path, only and only depend on position to the particular object, only and only depend on particular position objects. Now the total mechanical energy of a system is conserved if a force doing work on it are conservative. Okay, doing work are on conservative. Now, so in this case, suppose one object, so total mechanical energy in three different steps, means total mechanical energy for the is equal to 0, h height and capital H height, means this is the total height. Okay, this is the center one point of the h height and this one is the V0 means initial energy. Now the total in the ground level of the total energy is equal to mgh. End point of this total energy, mechanical energy, Ph is equal to mgh from object holding from this position. Okay. So now in the next, in middle situation of the, suppose in the h height of the total mechanical energy, in this case E is equal to mgh plus 1 by 2 mv square h. And now last one of the ground level of the in this situation. So P0 means in initial position, P0 this particular position, mechanical energy is 1 by 2 mv square. Okay. So now in this case, total mechanical energy in first h height Eh is equal to mgh, means this is the portion of potential energy of object. Okay. Now second one portion Eh means this particular height mgh plus 1 by 2 mv square, means that small potential energy, small particular potential energy convert into kinetic energy. So this is the remaining potential energy plus kinetic energy. Total energy is equal to same, means constant. And the last one E0 is equal to 1 by 2 mv square, means in the end point ground level of the total mechanical energy is totally convert into kinetic energy ground upper surface level 1 by 2 mv square, means that here kinetic energy, potential energy 0. Potential energy is 0 because of total mechanical energy is equal to kinetic energy. Now in first case, total mechanical energy is equal to potential energy, because here in the upper surface of in this region, kinetic energy is equal to 0. Kinetic energy is equal to 0. So here in this case, total mechanical energy is equal to potential energy mgh. Okay. So now here in the next case, EH is equal to E0. EH is equal to E0. Okay, because in the initial this mgh is equal to 1 by 2 mv square. Okay, now so mgh is equal to 1 by 2 mv square. Okay, total potential energy is equal to total potential energy totally converted into kinetic energy. Okay, upper surface in this situation, total kinetic potential energy, this one, in the ground level total kinetic energy means total mechanical energy, this both are same. Okay. So now the equation in the equation Vf is equal to under root 2g as capital H height means total height in this case. Now next step in the EH is equal to, in this situation, small h, base height and base one. So is equal to, which is in place, VH square is equal to 2GH minus H. This equation and this one, very useful. So now here again we explain all the things in the initial. In this case, total mechanical energy is equal to potential energy because of this object in steady condition, not moving condition. So in this situation, kinetic energy 0. In the ground level of this situation, potential energy 0 and kinetic energy maximum, means totally potential energy convert into kinetic energy. Okay.